Hello again. Time for another video lesson for data class. We're going to be talking about scatter plots and lines of best fit. So right in the previous lesson, we were looking at mathematical indices, which was a way of collapsing a whole bunch of different numbers into a single number. Now we're going to start into actual analysis with multiple variables at the same time. So kind of the classic way to do that for two variables is to create a scatter plot, right? One variable on one axis, one on the other, to make a comparison. Okay, in fact, it's so classic, you see these all over the place. For example, this little verse from the musical Camelot, which goes, "In short, there's simply not a more convenient plot for two variable statistics than this old scatter plot." And that's probably quite enough for me. It's a good musical, though. So, just to review, okay, this is what a scatter plot kind of normally looks like, right? You have your independent variable along your x-axis and your dependent variable on the y-axis. So, right, I'm investigating usually see if something changing in the independent variable would affect the dependent. So maybe say, for something mundane, like, the more minutes I study, hopefully the better my mark is. Okay, right. So you're looking for a controlled variable and see if it produces an effect in another one. Okay, so your data is out here. And in here, the data is mostly clustered together. So we might say this data has some kind of a trend, right? It appears to be moving upward, with the exception of this one down here. Okay, and we call that an outlier, right? If there's a point or two that doesn't quite match up with the rest, we call that an outlier. So you've been creating these for a long time, right? Would have started in elementary school, done it when you were developing functions, right? Certain patterns of dots that we turn into curves eventually. Okay, but for statistics, what we're kind of more interested in here is something like this. So if you were trying to do a report, right, and here if we're just doing hours of sleep, right, so seeing if there's a connection between how much you sleep and how well you do in school. If you're trying to do a report and prove that how much sleep you get actually does improve your grades, okay, which one of these graphs would you want to have in your report, right? Which one would be the clincher that says yes, how sleeping more definitely improves your grades? Okay, so maybe think about that for a moment. Which one do you think you would choose? Okay, and hopefully you would agree with me that the first one that I just incidentally highlighted here, this one is more useful because the points are very close to the line of best fit and are clearly moving up in this direction, like almost perfectly so. Whereas this one, yes, they're still trending upward, but they're way more spread out. Right, here's someone with a lot of sleep that did poorly, okay, and here's someone with not as much sleep that did a lot better, okay, and that doesn't really happen over here, right? They kind of move up at a fairly steady rate there. Okay, so this idea that this is kind of a quote-unquote better trend, right, it improves more steadily, this is something that is measurable, okay, or we're going to talk about how we can measure that. So here is first definition. Okay, so that's called basically this idea of how well they fit that line of best fit is called correlation. So correlation is a measure of the strength of the relationship between two variables. So that's what we're trying to measure, right? How good is that relationship? Again, if I flip back for a second, this would definitely correlate very well because they move together. And this one does not correlate as well because the points are more spread out. It doesn't follow a definite trend quite as clearly. Okay, so numerically, okay, we have this thing called a correlation coefficient, which we use R as our variable. Okay, again, I don't know off the top of my head why that is, but it's R. Okay, so what it is trying to measure for us is both the strength of a relationship, right? So how well it fits a curve or a model, okay, and the direction, right? So for linear, right, is it trending upwards or is it trending down? Okay, the possible values we can have for R range between -1, which is what we call perfect negative, and +1, which is perfect positive. Okay. And in between, right, dead center at 0, that means there's no correlation. So I'm just going to sketch a few examples of what that means. Okay, so I'm going to set up my little axis here. Okay, so starting with, we'll start with 1. Okay, so for perfect positive correlation. So that occurs when your data perfectly fits a line or curve of best fit. So sticking with the idea of a line for a moment, right, that would be a series of dots that go in a perfectly straight line, right? If I try to add a line of best fit for these things, it's going to go right through and not miss a single one. Okay, so that's what perfect positive looks like. Okay, now note, it just means it's going up. This is no indication of the slope. Like, it doesn't matter if it looks like this or if it ended up being a lot steeper. Okay, it's just, it means it's going up. Okay, so it's up and they perfectly match the curve. For perfect negative, so when R is -1, okay, same idea, but just the opposite direction. So something going down in a straight line. This is a very steep straight line. Okay, but this would be pretty much perfect negative, because again, if I draw my line of best fit, it goes straight through all the points. Okay. So as the value moves towards 0, so as it gets lower, it just means it's more spread out. So for example, if my R was, say, maybe 0.9, okay, a little less than 1, then it would be moving upward, but it wouldn't be perfectly straight, right? Pretty close, but not perfectly. So maybe something like that. Okay, so when I draw my line of best fit, okay, the points are really close to the line of best fit, but they're not perfect. Okay. As this value gets smaller and smaller, it would get worse and worse. Okay, so just to make it easier on myself, I'm going to draw the line of best fit first. So maybe if my line was like that, and the data it came from was like this, got a couple streaks there. Right, it's clearly moving downwards, but it's way more spread out. So maybe this is -0.5. Okay, right? It's kind of in between. Okay, so that's the idea, right? The more spread out it is, the smaller this value gets. Okay, so the smallest it can possibly take on, right? The worst case is when you have a correlation of 0. And there's actually 2 looks for that. Okay, the first one is carrying on this idea. So if the data points are just really, really, really spread out, okay, and there is no apparent direction for line of best fit, right? There's no obvious trend or direction that's going. Okay, I would say this has a correlation of 0. There's no pattern there. The other possibility for R equals 0, and this is tying into the slope idea, is if maybe they do make a line, but the slope is 0, right? If my points look like, and that's not quite 0, so I'm going to try that again. Okay, if my points look something like this, okay, right, a horizontal line going straight across. Okay, this also has a correlation of 0. And the reason this would be, if you think back to the graph I had earlier that had hours of sleep on the bottom and grades up the side, a graph like this would be showing that I have a whole bunch of people with different hours of sleep, and they all have exactly the same grade because they're all at the same level, which would suggest that how much sleep you get has no influence on the grade because it didn't change. Okay, so those are your 2 options for 0. Okay, so that's what it measures. Okay, related to this is what's called the coefficient of determination, which is just the square of that number. Okay, and what this is trying to measure is the degree of confidence you can have in predictions from your model. Okay, so for example, if r squared was 0.81, okay, which means that r was 0.9, right? Because 0.9 squared is 0.81. That means that I can say, right, that 81% of my predictions would be accurate. So if I go back here, this was my 0.9. It's the idea that if I extend my line of best fit, okay, make it a little bit longer, and I want to make a prediction, right? My data set was down here, but I want to predict when I get this much sleep, right? How high is my grade? Something up here. Okay, with this model, I can be really confident, okay, right? 81%, okay, really confident that this is going to be pretty accurate, right? Because it's all the data so far has been close to the line of best fit. It might be a little off, but it should be close. Whereas with this one, okay, if I were to extend my line of best fit, which I can't grab apparently, so I'm going to redraw it. Okay, if I were to extend my line of best fit and try to make a prediction down here, okay, there's my new point. Is that going to be accurate? Well, it's kind of a little harder to say because these are way more spread out. So, right, and if I square 0.5, right, r squared is 0.25. Okay, right, I can only be 25% confident that this is the exact value, right, that it's going to be really accurate, which makes sense because there's much more likelihood here that the point could be up here or down here because of how spread out the data was. Okay, so those are the two things. So for a brief example, have a look at the following three graphs, and I want you to estimate what you think the value of R would be. What is your correlation coefficient for these? Okay, so maybe pause the video and invite a neighbor to discuss what do you think for each of those. All right, so if you're back, hopefully again for the first one, this is pretty strong. You may have decided to go with R is like 0.8 or 0.9. Okay, right? Again, this is maybe even 0.95. Like it's pretty much right on, okay, with a straight line there. Okay, and I'll just draw that as well, right? They're really, really close. So the R value should be very close to 1. Okay. For the second one, okay, this is a downward trend, right? So, and they're fairly scattered from the line. So, because it's down, your value of R has to be negative. Okay, so maybe 0.6, okay, right? Not the greatest. Okay, and again, for the last one, hopefully you'll agree that this one should be 0, okay? There's no obvious place to put a line of best fit there. Okay. I do see a picture of a bunny if I try hard enough here, but that's not really a curve. Okay. So that's the basic idea. Now, you might be asking yourself, well, that's nice, but how do I actually get this number? So the process, you could do it by hand in theory, but realistically, you want to do this with technology. Okay. So here are some practice questions up here, but I'm going to do a demo of how to do correlation with technology for you. Okay, I'm going to do it twice, once with Google Sheets and once with Desmos. Okay, so what you might want to do is, again, pause the video, load Google Sheets in another tab, and try to follow along, right? Go back and forth, or maybe work with a partner to practice how this works. Okay, so I'm going to go into Desmos. Sorry, I'm going to go into Google Sheets first. So I've already preloaded the data here. Okay, my first column was my height, second column was my grade. So to get to the value of R and R squared, okay, I'm going to highlight my data, and I'm going to make a chart. So I'm going to go to Insert, Chart. Okay, now by default it gave me a column chart, but I don't want that. I want a scatter plot. So I'm going to scroll down here to Scatter. Okay, and I'm just going to shrink this a bit so I can see it a bit better. So there's my 5 points. And now I'm going to add a trend line to it. So I'm going to go over to Customize. And down here where it says Series, we're going to open that up. Okay, and there's a checkbox for trend line. So I'm going to check trend line. Okay, and you can see by default it gives me a line of best fit. So let's try to line that up. Okay. So a couple things you can do here. First, if I want to see the equation, okay, where it says label, I can click on use equation, and it's put it out there for me, right? So my equation would be y equals 0.584x. Okay, there's a little asterisk in there. It's just times. Okay, so this is my slope, and that would be my y-intercept is negative 19.3. Okay, that's the equation of my line. If I want to see r, okay, they have a checkbox for show r squared. Okay, so my r squared value is 0.853, okay, which is pretty good. And actually, I'll flip back here. So this was about 0.584. So based on this, my equation for the line of best fit from there was y equals, it was about, I think, 0.59x minus 19.6. Okay, my r squared is 0.853. Okay, and if I take the square root of that, okay, that would be my value for r, right? So my r is the square root of this number. So let's do that quickly here. So 0.853 square root 0.92. Okay. And I know it was trending up, so it would be the positive. It's 0.92. Okay, so that's how I got my values for r and r squared. I got r squared with technology, and I took the square root to get r. So again, that trend line fits very well. If I go back, though, I don't have to pick linear, right? You've learned lots of other models along the way. Okay, so the most common types you probably want to investigate, I could do polynomial, and you can change the degree here. So right now it's degree 2, so it's giving me a quadratic, right? It's got them kind of backwards. I've got 676 plus negative 7.73x plus x squared, and my r squared value is even higher, which suggests this might be a better fit. Okay, but yeah, you can do polynomial, so that's degree 2. I could play with the degree if I wanted to. I could do an exponential function. Okay, and it gives me the equation up there. And again, my r squared value. Okay, so those are your kind of typical 3 models, right? Linear, you can get quadratic from here, and you can get exponential. Those are ones you might want to test. And I can discuss that more when I'm back in class. Okay, so that's how you do it with Google Sheets. Okay, you get the graph, and you can get the equation by using the trend line feature. So I'm also going to show you how to do it with Desmos. Okay, so in Desmos, okay, instead of entering an equation, you're going to go to plus, and you're going to add a table. Okay, and same thing, I'm going to need to put my data in here. So I've got 163, 178. Okay, and then for y, I'll put in those numbers. Okay. Now, these numbers are all pretty big, so to see my points, I'm going to need to zoom out a whole lot. There they are. They're over there. Okay, so there are my points. Okay, to add a trend line, we have to do this manually. Okay, so what you do is you start typing in the variables at the top here. So it said y1. So y. Okay, the way you get the little 1 is you either type the underscore, okay, or from the keypad, if you go into letters here, that's this, a subscript b. So y1, okay, and just told me what it is. It's got a list. Okay, then instead of putting an equal sign, I use the tilde here, which is a little wave. Okay, so y1 is approximated by, and then I just have to start typing in what kind of equation I want and what kind of variables. So for example, if I was doing a line, right, that's your kind of y equals mx plus b. So I type m, okay, x. Now I have to do x1, right, again to connect it to what's there, and then plus b, okay. And you can see underneath, it's put out all that information that I had before, right? There's my r squared, right? So it's got an extra decimal place, but right, 853 rounding, and there's my value for r. Okay. And then for the parameters, for the slope, right, I have my 0.584 again, and I have negative 19 point, I'm guessing I copied that down wrong earlier. Okay, but it gives me all the information right there. So this is really only limited by what you remember about your equations. Okay, so there's the line. If I wanted to do quadratic, okay, the basic form for a quadratic is ax. So again, I have to do x1 squared plus bx1 plus c. Okay, that's the basic form of my quadratic. And again, right, we saw that 676 earlier, right? I get the same numbers, and it gives me my r squared. And you can see what the trend line looks like. Okay, so that's a couple different ways you can use technology to generate the values of r and r squared. So just as a future note here, you do need to get familiar with Desmos, because realistically on a test, this is probably the best way to do it, is that I'll get the iPads and put it in Desmos test mode so you can use it to get this information. Okay, for your assignment, okay, when that comes around, I'm not really concerned which method you use. Okay, but this is how you can get your correlation and get your lines of best fit. All right. So there's practice work for that. Okay, or of course you probably would rather work on finishing your assignment, so you can work on that as well. Okay, thanks for watching, and I will hopefully see you tomorrow.